from its characteristics to how it differs from other planets and more. Come along as we analyze the enigmatic Gliese 1214b exoplanet. Number 8. Gliese 1214b. Let's get straight to it. Gliese 1214b is a really unique planet that was discovered more than 10 years ago and has piqued astronomers' interest ever since. Why? Because, and we do mean this quite literally, its atmosphere is different from that of the majority of exoplanets identified so far. As you can see, numerous scientists have searched for planets that contain water both on the surface and in the atmosphere. One of the most important signs that the planet might support life is this. While there is water in the atmosphere of Gliese 1214b, it's not exactly in the usual form. That is to say, it appears to be fairly close to plasma. According to principal investigator Norio Narita of the National Astronomical Observatory of Japan, as the temperature and pressure are so high, water is not in a usual form, vapor, liquid, or solid, but in an ionic or plasma form at the bottom of the atmosphere, specifically the interior of Gliese 1214b. On Mauna Kea, Hawaii's Subaru telescope, 2 instruments were used to study the planet's light scattering. The astronomers came to the conclusion that there was a considerable amount of water in the atmosphere by combining their findings with earlier measurements. But once more, a sizable portion of it is in plasma form, making it not only incredibly unique but also not exactly safe in terms of potential future use. Because if something is in a plasma state, it must be extremely hot. Number 7. Weird planet, hot water. The planet, which orbits its colder, low-mass M-type star once every 38 hours, is situated 70 times closer to the Sun than Earth is to the Sun. It is located 40 light-years from our solar system in the constellation Ophiuchus. Additionally, as we're sure we don't need to remind you, the closer you are to a sun, the more heat and radiation you are exposed to. For this reason, the water on Gliese 1214b is so intensely heated that it has transformed into plasma. At high pressure and high temperature, the behavior of water is quite different from that on the Earth, Narita added. Water should be a supercritical fluid near the bottom of the atmosphere of Gliese 1214b, which is rich in water. While more research is needed for a location like this, it won't be any simpler for a variety of reasons. Not the least of which is the fact that the planet is 40 light-years away and 6 times larger than Earth. Additionally, the atmosphere is in such a peculiar state that there may even be 2 atmospheres going simultaneously. How does that function? There is, of course, the standard atmosphere that one would anticipate for a planet, and there is also the possibility that the planet may be covered in a haze as a result of the sun's intense heat. Therefore, that by itself will have an impact on how we attempt to find specific things within it. But there are also other things to think about in this situation. Number 6. Surface deficit. One thing we have learned about Gliese 1214b's planet is that, despite being a supergiant, again, 6 times larger than Earth, it is a planet without a solid surface. It is either a gaseous planet or a liquid planet, thus. We're leaning towards the latter given the plasma form and the liquid-filled atmosphere. However, since the sensors are damaged by the various gases and plasma in the atmosphere, we can't easily confirm that. So much of our knowledge is conjecture based on what we already know. We anticipate finding ionic or plasma water deep within the planet, according to Narita. But it's possible that we won't be able to locate hot ice high-pressure ices within Gliese 1214b. Despite the fact that liquid water is frequently regarded by scientists as a crucial component for life, Narita does not believe that the super-Earth will be promising due to its tight orbit, which is within the star's habitable zone. Although liquid water, specifically oceans, would not exist on the surface of this planet, he said that water vapor could exist in the atmosphere. So, regrettably, we do not believe that this planet would support life. Which is unfortunate because it could have been a candidate for world building even with just a liquid surface and a few other elements, but alas, it is not. However, even in its plasma form as water, there are lessons to be learned, which indicates that there is still more to learn. Number 5. Detection. The M-Earth project, which looks for the tiny brightness dips that can happen when an orbiting planet fleetingly passes in front of its parent star, was the first to discover Gliese 1214b. It's a pretty clever technique to go about finding planets, and as a result, many discoveries have been made. The sun was being blocked out by a planet every 1.5 days, showing that there was something going on and living there. But it wasn't until 2009 that scientists were able to go and further look at the data. And yes, that was Gliese 1214b. After that, scientists were able to examine the planet more closely and search for the many factors that contributed to its unique characteristics, including the environment we mentioned earlier. Number 4. Structure. As we briefly discussed, we have no idea what kind of planet Gliese 1214b is on the inside. We refer to that as a gaseous or liquid planet. There are many who believe that it is a gaseous planet, but this can't be totally confirmed because there haven't been any accurate inner scans. However, if it is a water planet, it would be truly unique on a grand scale because it would require a very specific type of liquid combined with the atmosphere to survive being so close to a sun. The plasma nature of the atmosphere is one of the main theories as to why it could be a water planet, though. Because one of the biggest tells of a watery composition can be that models of a water world contain steam, liquid, superfluid, high-pressure ices, and plasma phases of water due to the variable pressure at depth. Again, despite the fact that we have known about it for more than 10 years, all of this is currently largely conjecture because we lack sufficient data. Nevertheless, this does not preclude us from speculating and considering what else we might learn. Because as we learn more about this planet, we also learn more about the universe as a whole. Number 3. The desire to learn. What does all of the big phrases, statistics, and composition numbers we've thrown at you so far actually mean? Why should we be interested in Gliese 1214b and what it is? Even if we tried, we couldn't reach it because it is 40 light years away from Earth. Additionally, as was already mentioned, there is probably no way that it is a habitable planet, so why should we even bother to care? Simply put, because it exists. Whether we realize it or not, every planet in our universe is a mystery. Even the Earth and the planets that orbit it are a mystery because they are not only present but also exist in their current form. How did they become like that? Why are they currently acting that way? And the list goes on. With its plasma-form water in the atmosphere, the planet Gliese 1214b possesses something unique that we don't yet have in our own small region of the galaxy. Therefore, we must investigate it, see what we can glean from it, and only then move on. Additionally, like any good scientific experiment, we can test any findings on the following planet, which might resemble Gliese 1214b. We immediately have a pattern if those two planets are identical. And since there is still so much about science that we don't yet understand, patterns can help lead to important scientific discoveries, which is exactly what we need in the field of astronomy. In fact, we bet that before watching this movie, none of you had even heard of this planet. Thus, the fact that there was a gap in your knowledge is sufficient reason in and of itself to go learn more. Number 2. The cosmos in general. Gliese 1214b's potential role as a dot on a chart of every planet in the universe is another reason why it is so crucial to us on a scientific level. How do we interpret that? Well, if you look at our solar system, you will see planets like Mars and Mercury that are empty, as well as Venus, planets like Jupiter, Saturn, Uranus, and Neptune that are gas giants, as well as small objects like Pluto and, of course, Earth. And even while there is some diversity among humans, there is yet so much more in the cosmos that is still unexplored. There are planets in the universe that have a pink color and others that are not spherical but rather have an egg-like form. There are those that black holes are slowly consuming. Those that contain a portion of diamond that, if mined, would be worth far more money than you could possibly imagine. And now, in Gliese 1214b, we have a planet with a plasma water atmosphere. So yeah, wouldn't you agree that's pretty cool? One of the wonders of our cosmos is the variety of planets it contains. To determine if we have found everything or if more remains to be discovered, we need to locate these planets and then line them all up. Knowing that there is so much more to discover and that the cosmos is essentially limitless, especially if you hold the belief that it expands every single minute of every single day, is fun in and of itself. Number 1. What happens to Gliese 1214b next? There is still much to learn about what lies ahead for our amazing plasma world. Since it is unlikely that we will be able to send a probe there in a reasonable amount of time, we will instead use the various telescopes and satellites that can observe it to learn more information about it. We still don't fully understand its atmosphere, terrestrial makeup, formation process, or the different top-to-bottom layers that contribute to its current state. We'll investigate it further, and when we learn more about it, it will be a significant event. Thank you everybody for watching. What do you think of this examination of the enigmatic exoplanet Gliese 1214b? Tell us in the comments section below.